Okay, what's up, guys? I hope you're good. Anyways, here with me, I've got several desktops that are not working. Yeah, and they are not really low end. They're decent motherboards. Anyways, at this point, they're probably a couple of years old now. At least 4 years, I think, on each, because it's DDR4, not DDR5. So yeah, still good, but yeah, getting old now. Anyways, this one doesn't power on, so I've plugged the test power supply over there, and you can see the orange light on the power supply to say the power supply is on. However, when I'm trying to start the motherboard, the front connector is over there. So when I try to start the motherboard, there is no response at all. So the owner dropped it like 30 minutes ago. They said the motherboard was working yesterday, and today in the morning it just wouldn't switch on. So I'm just gonna tell you what I've done. I've tried to reset the CMOS, of course, which I believe the owner also tried already. However, it didn't work for me or for him. So just to check that my power supply works, of course, I'll short green to black. Okay. The light, the LED has turned green instead of orange, so the power supply is now on and running. You can see this fan is spinning over there. So this type of power supply has got two fans, on this side and one this side. So yeah, and it's also a modular power supply, which makes it ideal for building a PC. Anyways, we're not there. We are here. Try to kind of zoom it out and reduce the amount of stuff on the desk. This mat is a bit small for a motherboard. This is like a small form factor motherboard. What if I'm getting a full size? Yeah, it won't even fit here. Anyways, what I've done is I've checked for a short. So always, if I get a dead motherboard, this is what I do. First thing that I do, if the motherboard is not switching on, I come to the CPU and I check positive and negative, which is buzzing. I've got a 2 ohm resistance, so it's a bit tricky because I prefer it to be 00. Then I know it's a dead short, but it's a 2 ohm resistance, which could mean that the CPU is fine or there's no problem, but it's just low resistance. But this is a desktop. I'm not measuring the phases. If I was measuring the phases like on the coils and getting a 2 ohm resistance, I would say it's fine. But I'm measuring here on the 12 volt. That's basically the main power down. At this point, it simply means we've got an issue with one of the MOSFETs, or more of the MOSFETs. Now the CPU phase is now linked to the main power down. So there's now a problem there. Remember, the MOSFETs are supposed to switch the voltage from 12 volts to like 1 volt. So they'll be working as switches on off with the assistance of a regulator like that one there, the controller chip. It will control those MOSFETs such that they produce something like 1 volt or 1.2 volts depending on the settings. Anyways, now we're getting a 2 ohm resistance over here, which is a clear indication that we've got an issue around the CPU. Now the downside to that is there is a chance that before whatever MOSFET did fail, it probably sent 12 volts to the CPU. If it did, this processor is dead. So I'm gonna check it out. It's an AMD CPU, AMD Ryzen, and the socket is an AM4 socket. So yeah, it's a Ryzen 5 1600. Okay, made in China, diffused in the USA and made in China. Interesting. Okay, so what I do always is I will remove the CPU. So if you remember from the last video when I was working on an Xbox, I couldn't remove the CPU, the APU, because it's mounted onto the board, so I cannot separate it from the board to check what's wrong. But with the desktop, anyways, simply because I couldn't remove it, that's why I had to lift the coils until I found the coil which was linking the CPU phase to our main power rail. I didn't notice I was out of frame. Anyways, as I was saying, because I couldn't remove the APU from the board, I had to find a way to isolate the APU phases from the main power rail. So that was only possible by removing these coils. So in this case, we can skip that part. Reason being, we can remove the APU. Then we can check the MOSFET which one is shorted, because it's not possible to check the shorted MOSFET when you have an APU present, because the APU or the CPU or the GPU, they all have got low resistance. So if you check with that present, you will not see the difference. You will get a low resistance anyhow. So the best way is to either remove the CPU if you can, or if it's in a console where you can't remove the CPU, lift the coils, isolate the APU from the main power. First fix the main power, then reconnect the coils. Anyways, I'm gonna remove the heat sinks of the phases, because wherever you see such a heat sink, it simply means there is a phase underneath. So let me remove this guy, and then we can proceed from there. So here we go. So they obviously feed safety. Sorry about that. Always sorry about that. Someone who just walked in, so I was responding to them. Okay, so here we are. Okay, cool. So we are checking these phases. They are all probably going towards the CPU, but working differently. If it was an Intel, I would say some are going to the PCH, some are going to the CPU. With AMD, I'm not so sure if it's got the North Bridge and South Bridge like the Intel-based systems. You correct me if I'm wrong somewhere. Anyways, let's check the MOSFETs one by one until we find the one that's shorted. So because my probe is a bit thick, what I'll do is this: I'll attach a tweezer to one end and then I'll squeeze it in there. Well, okay, check this one. We are fine. Okay, check this one. How was that? Oh no, we're fine. I don't know how it was giving me a 0 ohm resistance. I don't know where I put it. Anyways, we're fine there. Let's check this. 8 kilo ohms were okay. Now I've got to try and squeeze. Okay, we're good. This one, we're fine. 29 kilo ohms. And here we are okay. We've got like 64 kilo ohms, I believe. Okay, and here 17 kilo ohms. So here we're okay with these phases. So now we'll check those ones. I'm pretty sure these are the ones that are going to the CPU, like the feeding this with the processor. And here we are good. Check this. Oh. Okay, we are fine. If you check this. This one is dead. No matter how I try to make it sit, this one is dead. So you can see by the coloring This is coming from the ATX, from the CPU connector there, the power connector for the CPU, and it's following this line straight. So it goes also this way, but it comes this way. So it first goes into this MOSFET and out, into this MOSFET and out, into this MOSFET and out, into this one and out. So if there's a MOSFET that's gonna fail and link the positive of the CPU, of the power supply to the CPU's phases, it will be one of these. It will be one of these. So checking this one, it's also giving us a 0 ohm. So they'll obviously give us 0 ohms. Reason being, they are all connected to different coils, but these coils are all connected together on the other side. So if I want to know which one exactly it is without having to lift random MOSFET, I can simply remove the coils. If I've removed the coils, and then I'll check, because the MOSFETs will no longer be connected together on their output. They will still be connected together on their input, but no longer on their output. Then I'll know which one is faulty. So let me just see which is easy to do. Removing the coils or removing random MOSFETs. Let me try to lift one coil and see how easy it is. If it's something that's hard to do, then I'll just fire up the water station and lift the MOSFETs until I find the faulty one. No, this is not a wise idea. This is not a wise idea. These motherboards, they need a lot of heat anyways, so that's not going to work. So let's use a water station. Then we'll pick the MOSFETs one by one until we find the one that's faulty. So while the water station is heating up there, I'll check these MOSFETs, the ones on the top. So this one says it's fine, and this one gives me a 0. No, this one says it's fine also. If I check this one, no, this one is giving me a 0. Is it? No, it's fine. And this one is fine. Here, okay, that's fine. And that's fine also. If I come here, that's fine. And if I come there, that's fine. So our issue has to be with one of these four. One of those four is the culprit. So if you ask those technicians that have been doing this for a very long time, they'll tell you that it's wise to lift. When you're changing a MOSFET, you need to change all of them and their controller. Okay, there goes one. Let's check what we've got. We're still on 0. Let's check the MOSFET itself. MOSFET is good, so you're okay. We won't touch you. Let's come to number 2. Try to lock the focus there so that whatever I do doesn't affect the zoom of the camera. We are still on 0, and MOSFET is fine. Okay, my heart is pounding now. What if it's none of these? Okay, here comes number 3. And what's left on the motherboard? It's still on 0, 0. There is no way the last MOSFET is the one that's actually faulty. snowing. What are the chances that the last MOSFET is the one that's faulty? Now that's interesting. Yeah, and she's dead, you can see. So there's our culprit. We can throw this away on the side there. Then we have to put back these ones. So I'll introduce some new solder there. So that these MOSFETs can flow much more gentle and smooth. Okay, what an awkward angle. Okay, cool. So let me put back these 3 MOSFETs now, and then get a replacement for that other spot, the last one. Okay, there goes number 1. Remove any excess solder there. Okay, here comes number 2. Okay, here's number 2. Then I'll remove any excess that's squeezed out. Okay, let's put the last one. No, not the last one really. It's still gonna be a need to find a replacement MOSFET for the last position. Okay, let's pull out the excess. That was wrong. Anyways, I managed to take it off. It's fine. These clips are making it very awkward for me to fit my soldering iron there. And I'm gonna check to see that these MOSFETs are sitting properly, of which they are a bit skewed. I'm on a situation where I've shorted out the gate to drain. Okay. Now let me get the last MOSFET to replace all of that. Anyways, by tomorrow, definitely. How before when you and anyway, whatever time you come. Alright, cool. So this is also an Asus Prime H310. This is an 8th generation Intel based motherboard. Anyways, this one does not work, so I'm gonna check a MOSFET format. This one seems to be on the main power side, so let's yank it off. Okay, here we go. Now we can put it there. That's fine. That's fine. Okay, let me pull out the excess solder there. Wow, it's not even clinging to my soldering tip. I have no idea why it's doing that. I've even cleaned my soldering tip. I thought maybe it's not okay, then I'll scrape those off. Oh, the power just cut. I'm gonna pause the video for now until the power is restored, then I'll continue from there. Okay, the power has been restored, so I think I can continue with the video. Anyways, while the power is off, I just took a chance to brush off any excess solder that might be left on the motherboard so that I cannot create unnecessary short circuits. Anyway, so now I'll put the I'm gonna check actually first. I'm gonna check the CPU connector there to see if we still have got a short. And we do not, so we're getting a resistance that's pretty high, and that keeps going higher. So okay. See, we're getting like 13 kilo ohms or something like that, so we're good over there. What I'm gonna do now is I'm gonna put back the CPU, and hopefully it was not fried by the process of those one of those phases failing. The only way to find out is to connect. But I can be without. All we need to do is to check if the machine is working really. That is what we are concerned about. So yeah, I'm gonna fire up the power supply. Do I get anything? Okay, no response yet. I will need the CPU fan because it's the only way we will know if this machine is running. So I'll just lay it on top of the processor actually. Okay, let's test. And there we go. Right on the first attempt. This is fixed. This is working. Okay, so what I'll do now is I'll put back the heatsink properly and the heatsink for the phases here, and then we can test the machine. Which side am I supposed to put first actually? Okay, we go in like that, and then comes you. screw, and we are good to go. So CPU side, we are done. Let's come to the phases now. This I believe sits like this, and then we can go screw it up. Sharp, fair enough. RAM. I don't know if this RAM works because it came with one of the desktops which is not displaying. So I'm praying that it works actually. Unfortunately, I don't have HDMI, but I do have DP. And the unfortunate part is that my DP is kind of permanently mounted. Okay, I'll use the TP from the second monitor over there. Okay, that's in. Let's go ATX and let's go CPU. I hope it will work with just two. I know it's supposed to work, but yeah, I'm just hoping it's not gonna misbehave because there's a missing connector there. As I wait and hope for a display. I took off the CMOS battery, so it's most likely gonna restart. Yeah, before I could even finish my statement, it did that. Okay, this is the third time now. Let me get a keyboard just in case my cable is not connected properly. No, we do not have a display and we do not have a caps lock blink. Okay, this looks like it's in properly. CPU is there, RAM is there, but I said this RAM is coming from a machine without display. Let me get a RAM which works. Okay, so this is a ballistics by Micron, and it works from what I know. Okay, I'm gonna put a new CMOS battery in there because I don't want it to loop again, but it still hasn't posted, so it's definitely gonna loop. Okay, let's fire it up. Motherboard is on. Also remember, the phase that failed is going to the CPU, so it's possible that the CPU is gone. But if it were gone, so right over there I've got an LED for VGA, so it hasn't detected that VGA cable. So I believe now the issue, oh yeah, it's a VGA issue because there the keyboard is on. So you can see caps lock response there. Alright, so okay, fair enough. At this point we know it's probably needs VGA, so I'll call VGA now. instead of DVI. So this VGA cable comes from my other monitor, because I've got 2 monitors on my desk here. Okay, and that monitor I'll remove HDMI from it. And do we get a display, or I have to restart the board? Okay, let me restart the board. Okay, power it on. At this point it has to do with the cables. Okay, DRAM, CPU, all the codes are still on VGA. Okay, I don't know if it's displayed without the graphic card. If the previous user set it to display without only one graphics card, then it's tricky. I'll need a GPU. Yeah, at this point I believe I will need a graphics card, because the motherboard is on